Welcome to something special. Welcome to TEDx. This TEDx event is part of a global conversation that takes place every day in every corner of the world. In schools, in theaters, in workplaces, even in prisons, people gather to hear the best ideas bubbling up in their communities. More than 3,000 TEDx events are held every year in 170 countries. It's a remarkable thing. TEDx events are self-organized under a license from TED, a non-profit organization devoted to discovering and sharing powerful ideas in the form of TED Talks. It's not TED itself, but your local TEDx team of volunteers that has done all the work to put on today's event, including booking all of the speakers. It's this team's ideas, dedication, and time that have made this possible. We really hope today's program sparks an exciting conversation. This is a day for curiosity and for skepticism, for inspiration and for action. The more you enter into it, the more you will take out. And now, on with the show.
I'm a part of a project on 2D material development and graphene. So that's what I'm here to actually talk to you guys about today. And when I mention 2D materials, what I mean is a material that's stable across a single layer of atoms. And we're interested in these materials because they have a unique and pretty strong characteristic in regards to their physical properties. Now, the most common of these materials today is graphene. It's basically the gold standard of these super materials. But that's not actually what my background is as an engineer. I'm a mechanical engineer. I study thermal science and energy system design. So actually what I want to talk about to begin with is how I actually got there, how I got to studying and having this interest in graphene and 2D supermaterials. And what my background was in when I got to my doctoral studies as an engineer was solar energy, and the use of solar energy as essentially a means to store potential energy as a source. And that has to do a lot with the issues around solar energy and being able to use it today. So solar energy is actually an old technology. It's been around for a while. And the hiccup in regards to getting it to be more mainstream and used within our energy sector has a lot to do with when we need energy and when solar energy is available to us. Essentially, those things don't overlap. And my area of research when I was in my doctoral studies and my early career as an academic was in solar thermochemical energy storage. So could we actually figure out a way to store solar energy from radiation as a chemical substance that then we can use later on? And so what I found later in my career is that in order to drive this technology going forward over the next decade, starting now, is we need to investigate materials. Okay, you actually have structural materials and energy materials that can help us with this infrastructure. To promote solar energy just a little bit, you might have heard this before. If we were able to harness all the incident solar radiation that we get here on Earth, it would more than meet our energy demand. But the issue with that is essentially how we can use that energy within our current energy infrastructure. Okay. So what I found is actually, especially when I got here to Chengdu, is that I needed to branch out my interest as an engineer, especially in regards to research. I couldn't just focus on solar energy applications and system design anymore. I needed to move into a different area that actually would connect to multiple engineering topics. And another reason why I had to do that was if you actually look at this solar energy map here of China, red means good, okay, yellow means pretty good. That's where I'm from in the United States, a yellow area being from Florida, the southeastern part of the United States. But here in Chengdu, it's blue, okay? and it's kind of in the middle of China that this color is happening. Essentially, Chengdu is the worst place on Earth in regards to the areas where humans live to absorb solar energy. So I kind of found myself a little bit lost here in regards to writing proposals and getting research funding as an academic at Sichuan University, because they're not interested in solar energy here, okay? But what they're interested in is things like other alternative energy sources, wind, hydropower, and specifically energy materials, because of what use they would have. And so I kind of transitioned more recently. I still have this interest in solar energy, specifically photovoltaic cells. But now I'm focused on other energy systems like EV vehicles and transportation area, as well as just general electronics and personal devices and smart devices. And there's a lot that 2D materials and graphene can actually do for this, for each of these areas. So for solar PV, imagine having a solar panel that's flexible and transparent. We can place it on any external surface, say a building, window, so that we can actually drive up our energy usage with solar energy. Likewise, with EV vehicles, if you have an internal combustion engine car today, you drive it all day, you run out of gas or petroleum, you go to the petrol station to fill up. Right? How long does it take to fill up the vehicle? It takes maybe minutes to do that. If you had a Tesla Model 3 and you drove it around and you exhausted its battery power, how long would it take to charge that battery? It takes hours, it takes half a day, maybe more than that, to charge that battery. Okay? Well, there are techniques where we can improve lithium-ion batteries, which is generally used in those vehicles, using super materials like graphene, but we can also replace those batteries with supercapacitors that are designed with graphene. That turns that charging time from hours to minutes. All right, so now the energy density increases greatly for batteries. With electronic devices and smart devices, imagine not having to actually carry around your iPad, your rigid devices. Instead, they'll come with you wherever you go. You can use them wherever you go, and you don't actually have to have them physically with you. You have access to your information and to other information throughout your life and where you're going to travel from office to office or from your home to office. So that's the potential that I see with graphene. Now, how is it that graphene has access to all these different applicational categories? And it's because what happens when we grow graphene? Right, so as I said before, graphene is a single layer of carbon. Okay? It relates to graphite. If you ever heard of graphite, or if you've written with a pencil, graphene is essentially a single layer of graphite. Okay? And when we grow it, it grows in a hexagonal honeycomb-like structure. And if effectively we can grow it, it then has physical properties that are very unique. Okay? It's transparent. Nearly 90% of all light can pass through it. So that means its optical properties are extreme. Okay? But it's also very durable. We can bend it to whatever shape we want to. But also it has a tensile strength that's 200 times greater than steel. Also, it has great conductive properties both electronically and thermally. So if an electron passes over its surface, it does so in a very efficient manner. There's not a lot of loss. But the same with heat transfer. We can pass large amounts of heat over it as well. And it also works as a great separator. Okay? What I mean by that is it would filter out the smallest of molecules. So something like hydrogen wouldn't be able to pass through its surface. But at the same time, it does allow small ions to permeate through its surface. So it has a great functionality in regards to being a medium material as well. So graphene, in terms of its future application, will be essentially applied to the area of solar cells, since it has this transparent capability. It can be applied to lithium-ion batteries to make them more efficient and less expensive, so that we can have an extensive fleet of EV vehicles throughout our society. It can also be applied with electrochemical devices to support catalysis, due to the fact that it is a great medium for separation and as an electrolyte. And hopefully we can apply it and design supercapacitors with the material in such a way that at the end of the day your cell phone is essentially at zero charge. If you plug it in, it's going to charge within a minute. Okay. And so that's the future that I see with graphene. So a number of you probably are thinking of investing or getting involved in areas like alternative energy and solar power, maybe electronic vehicles, autonomous vehicles. You're interested in computing and machine learning, cryptocurrencies and blockchain technology. Well, graphene has a role to play in all of these areas. So definitely invest in those technologies today or this next decade because they're going to take off. But in the following decade, don't forget about graphene. And don't forget about the companies that are essentially going to benefit from that technology and where it will be in about 20 years from now. My research group, we're focused on large-scale graphene development and production. And we're close to our breakthrough. And so pretty soon you should be able to see graphene throughout the market commercially being sold for touchscreen technologies. So thank you for listening to me today. That's what I have. Goodbye, everybody.